Good morning, everyone. Welcome to Attacking and Defending the Microsoft Cloud, Office 365 and Azure Active Directory in South Pacific with Sean Metcalf and Mark Morowczynski. Before we begin, we have a few brief announcements for you. Please stop by the business hall located in the Mandalay Bay, Oceanside, and Shoreline ballrooms on level 2 during the day and for the welcome reception at 5:30 tonight. The Black Hat Arsenal is in the business hall on level 2, and please join us for the Pony Awards, which, correction to prior announcements, are in Lagoon JKL at 6:30 today. Lunch will be served in Bayside AB immediately after this session until 1:30, and don't forget the merchandise store on level 2 and session recordings from Source of Knowledge. They have a desk on every level. Now, please ensure that your phones have been placed on vibrate or silent to avoid interrupting the presentation, and welcome Sean Metcalf and Mark Morowczynski.
Hello and welcome, Black Hat. I'm Sean Metcalf. I'm the founder of Trimark, a security company. We help organizations better secure their Microsoft platform, both on-prem and in the cloud. I'm a Microsoft Certified Master in Active Directory, Microsoft MVP, yes. And I'm back at Black Hat, so I'm very happy to be here. I have spoken at a number of conferences, and I'm very happy to be back. I'm also a security consultant and researcher, and I post some interesting security stuff on adsecurity.org. The slides will be posted there after this talk.
And I'm Mark Morowczynski. I'm a principal program manager in the identity division at Microsoft. We're responsible for Active Directory Federation Services, and Azure Active Directory. And I work on the customer experience team. I work with customers on their deployments of Azure Active Directory. We provide guidance, but also take some of the learnings and the feedback from those deployments and work it back into the product to make it easier for everybody else to deploy. So this talk started based on a Twitter conversation. Last year at Black Hat, Sean did a really good session around moving from a workstation to domain admin. I thought, oh wow, that'd be really good. We should do something like that for Azure Active Directory. And Sean said,
yeah, let's do that.
Let's do it. So we submitted our talk. It got accepted, which was great. I've never been to Black Hat before. This is my first time. This has been excellent. So this is what we're going to talk about today. First, we're going to give you a sample customer about kind of how customers have moved to the cloud. Sean's going to cover some attacker recon as well as some attacking the cloud. I'm going to cover defending the cloud. And then the last part is going to be a bunch of go-dos. That'll be the time to get out your camera, take a picture, send it back to the mothership, making sure that we're doing best practices and following the proper guidance. So let's go ahead and meet that customer. The customer is Acme. They are the largest manufacturer and distributor of anvils in the world. They are headquartered right here in Las Vegas, Nevada. They have 500,000 employees, and they operate in 140 countries. And they're starting to think about maybe they should move their business to the cloud. They're not sure if this is the right thing for them to do or how to get started. They're kind of lacking some direction. But the good news is they just hired a new visionary CIO. And that CIO is Wile E. Coyote, a longtime customer, now employee. Get that sweet, sweet employee discount. He has surveyed the desert. He has his priorities, and his number one priority is we're going to the cloud. Okay? So Acme puts together a project team. This may look like some of the similar project teams that you've worked on. We have our identity architect who really is excited about this project. They want to fix all of the previous 10 to 15 years identity and access management problems they've had, because this time we're going to do it right. And then we have our collaboration architect who is kind of excited about this. They're not too sure what does this mean from a job performance perspective going forward. Are they still going to be employed after this project's done? So they're a little kind of standoffish. We have the identity engineering team who is actually going to go push all the buttons on this stuff. And they don't want to really get started on anything until we have all these use cases sorted out entirely. Okay? Then we have our collaboration engineering team. And they're pretty much looking for any reason to not do anything. Does anyone work with anyone like that? Or is that just Sean and I? Okay, just checking. And then we have our security engineering team. The answer is absolutely not. Not quite sure what the question is. And then lastly, we have a key component, which is our desktop engineering team, who is not present in any of these meetings. Okay? I love the desktop stuff. Come on. All right, but they're never there. Okay. So Acme gets started. They decide Office 365 is what they're going to do. They move their first workload. It's going to be email, and they're going to deploy Azure MFA because they want to increase their security posture, which is great. They do their pilot group, which is usually IT. They sync them over, and now they're starting to look at all the different use cases they have in their environment with their different employees. And this is where Acme starts to get in a little bit of trouble. They start getting some analysis paralysis, right? And right now, the scenario they're trying to work out is a user was registered for Azure MFA. They lost their phone. They got a new phone. They immediately got on a plane. And while they were on that plane, they were registering for Azure MFA. The Wi-Fi on the plane went down. How in the world is this person going to access their email while on the plane? So while Acme is working through this hypothetical situation that may never happen, it's probably never going to happen, something is much more sinister afoot. And that sinister thing is Sean.
This is kind of cool. I get to play the attacker. While Acme is going through this process and figuring out what they're going to do in the cloud and how they're going to configure everything, and they've already moved some people in there, they really haven't looked at the security of it yet. So what's happening? Meanwhile, there's an attacker that is looking at this environment. Let's see what we can find. One of the first things that I usually look at is DNS, because it's easy to look at. No one knows that I'm looking at it. In fact, I scan the Fortune 1000 companies to see what MX records they have, to see what their mail exchangers are. This gives you a good idea as an attacker to figure out what sort of security posture their email is what they have. And so we can see that organizations will have Proofpoint or Office 365 or Cisco or a number of other type systems. So if I, as the attacker, am designing an email campaign, I'm going to figure out what they have so that way I can test it against something similar so I can have a better idea of what might work and what might not. But often more interesting are the text records that are in DNS. These can be pretty much whatever you want them to be, and a lot of time organizations need to set a domain verification or site verification record. This is usually because they want to go with a third-party app or SaaS app, and they have to prove that they own this domain. And in doing so, they have this record in DNS, which again is visible to everyone. So this means that through a DNS query, I can get some really good information about what kind of enterprise apps an organization may have. So what does Acme have? Well, we see they just went to Office 365. So if I'm an attacker and I'm very intent on stealing the secret Anvil manufacturing process that Acme has, I can look to see what they have in their environment just by doing some DNS queries, possibly. These don't need to persist. Very often these can be removed soon after they've been verified and then just clean them up out of DNS. So we know they have Atlassian, they have Cisco, Citrix, Dropbox, and WebEx. Why is this interesting? Because if I'm an attacker and I want to put together a phishing campaign, what I want to do is target it to something that they may feel relevant. So I may send an email to all Acme, or all the email addresses I have at Acme, at 7 a.m. on a Monday morning, say, there's been a WebEx security issue, you need to update your WebEx or you will not be able to connect to your meetings today. Could be pretty successful. Or, since I said Atlassian, Avinash realized recently that Jira had a potential misconfiguration for a large number of companies that could leak some information about their internal environment. So I could look at to see if Acme has Jira, because they have an Atlassian text record here, and see what else I could find through that. The other thing that's pretty interesting is the federation configuration. So I want to see if Acme has some sort of federation. Do they have ADFS on site? What are they doing with that? How are they handling their authentication flow? And there's no real good naming standard for federation, so I can try FS, SSO, STS, etc. And at DEF CON a couple years ago, I talked about if you could pull this token signing certificate off of the federation server, then you could use that potentially to spoof and create your own forged SAML tokens to then get access to all of those federated apps. So think Workday, think Salesforce, think other big name company that sensitive data could be in. And a few months after that, CyberArk had a post about what they called the golden SAML attack. And they released a tool that could actually do this. Once you have the token signing cert, you could create these forged SAML tokens and then access these federated resources as if you're that person. And early this year at Troopers, Doug had released this tool called ADF Spoof. So Doug Bierenstock from Mandiant had done a talk there with Adam, and they talked about how you could extract this data, this certificate data from ADFS, and then also, right after you get that, generate that SAML token and get access to that application. In that talk that they had called I am ADFS and so can you, Doug and Austin talked about ADFS adapters, which is not all that well known, but ADFS has these adapters where you typically have the authentication flow where the user authenticates to AD and then they connect to ADFS, which then will give them that token. But an adapter says, wait, there's one more step that we have to do. So for example, you could have Duo MFA that needs to happen next. And when you have something like that, you're going to have a DLL. And they talked about cracking open this DLL and looking at the code inside of it and modifying this code so that way instead of just doing the MFA part, if you submit it during that logon page, beep beep, I'm a Jeep, it could run PowerShell or potentially something far more malicious. So this is some amazing persistence once someone gets on that ADFS server. So it's critical to understand that once you have a federation server, you need to protect it like it's a domain controller, like it's a tier 0 system. Protect those certificates. And make sure you're pulling the logs out of your federation system into your SIEM along with AD as well as your Azure AD logs. Then you can correlate those to figure out what's going on. What's interesting to me is that there are a number of different applications or cloud apps that often require some sort of synchronization from your on-prem AD. And all that you really need is a user account in order to send that, gather that information and send it up to that cloud environment. Obviously, if you have Office 365, you're probably going to have Azure AD Connect. But IT doesn't necessarily know what else is in place because, again, all you need is a regular user account. So I did some Googling to figure, oh, sorry, Mark. I used Bing to then, I used Bing to then Google Active Directory Sync Tool, and I found a number of synchronization engines that you could install. And I put some of the more well-known ones here. So if you're using these services, it might be possible that you have a bunch of different systems that are sending user data up to that cloud environment, and potentially group data. So you want to be aware of that. So let's focus on an on-prem environment. Again, at DEF CON a couple years ago, I talked about attacking Azure AD Connect and the fact that Azure AD Connect, using the Express install, would configure itself to do password hash sync, which generally we think is a good idea. But you have to understand the implications of what that means and what those rights are that are required for it. And Azure AD Connect is not the only system that would send password hashes, in this case, a hash of a hash, but there are other systems that may send the password hash from AD directly to the cloud system. So you want to be aware of those. But let's take a look at what we can do to attack an Azure AD Connect system that has used the Express install. It's going to have these rights configured. It's going to create automatically an MSOL account. It's going to put all this information in the description field, which is great for me, because then I know what it's installed on. Then with this, I can either check to see if there's additional rights that are configured for this account, or even better, if there's not that information, I can use PowerView's invoke ACL scanner to see what rights are actually configured at the domain root that provide, or what accounts have DS replication get changes, DS replication get changes all, which are needed for a DC sync for Mimikatz for an attack, but ultimately Azure AD Connect would need that. So here we see it's our MSOL account. So we're going to look at our Azure Sync computer, figure out where it is in AD. It's in the root server's OU. So our next step is to figure out how can we get admin access to that server in that location. So we use PowerView again, find GPO computer admin against that OU, and we can identify that there's a server admins group in Active Directory in the root group's OU that is added to the local administrators group for that OU, which means that if I can compromise an account that's in this group, I can control and administer that Azure AD Connect server, along with other servers, which could be interesting. But there's also a second GPO there called server config. And server config, I'm not too concerned about what settings it has. I'm really interested in the delegation. There's 3 different server tier groups that are configured with modify rights to this GPO. That's a little odd, but we see that a lot when we do security assessments at Trimark. And again, all I need to do is compromise one account that's in one of these groups to be able to modify this GPO that then applies to that server's OU. So I can add a member to administrators, I can run code, I can pretty much do whatever I want at that point. So this is a slide that kind of summarizes what I just talked about. The key takeaway here is that you want to treat your Azure AD Connect server as if it's a domain controller, especially if it's doing that password hash sync. And any other system that is doing something similar. You want to protect it very closely, because compromise of a regular server admin account, which may not look that important, could ultimately prove disastrous and compromise your on-prem AD environment. So we're pretty well understood about how the on-prem AD works, or for recon of that AD environment. You have an AD account, you can look at users, you can enumerate group membership, typically everything, as long as you can connect to a domain controller in that domain. Azure AD is a little bit different. It's the same. You need an Azure AD user account, but now you don't need to be on-prem. You just need to be able to connect to an Office 365 service, which usually means the entire internet. Also very interesting is we can also usually identify email addresses for that tenant or within Azure AD without having an account in the first place. So Office 365 Creeper, or O365 Creeper, is a tool that's very interesting because you give it a list of email addresses and it will attempt to authenticate to the Office 365 authentication page, and based on the result code, will say this is valid or this is not valid. So simply by doing this, we can identify what email accounts are valid logins for that Azure AD environment. And then the last three that are here enable us to do some user and group enumeration once we have a valid user, name, and password for that environment. Because of course, once we have a user list, we'll do something called password spraying. I think most people here know what that is, so I'll cover it very briefly. We have a list of passwords that we know people tend to use. We're going to try those against our user list, and then we're going to sleep for a little while, and then we're going to try another one. And this avoids lockout because we're trying one password against all the users, and then we wait before we try the next one. But Sean, we use symbols in our passwords. Yeah, I got you covered. Everyone knows this. So then we just continue on, and we continue iterating through this until we get username and passwords for that environment. Here are a bunch of tools that are available that will do password spraying against Office 365. This works because of legacy authentication. Legacy means all of the old stuff that is still in use on the internet. So POP, IMAP, SMTP, if people are using POP clients like Thunderbird, or if they're using apps on their phone, they're using legacy authentication. But legacy authentication, these old protocols don't support MFA. So even if you've enforced MFA on these accounts, I can still use legacy authentication to password spray these accounts and authenticate as them. So let's use Mail Sniper and do some password spraying against this Acme environment that's in the cloud, that they put a bunch of people in there but really didn't do a whole lot of security around it. They forgot to disable or decided not to disable legacy auth just because, and we are able to find passwords for a bunch of users. Okay, let's put that to the side for right now, and let's focus on how we can detect this. Well, unfortunately, by default, in order to look at these Azure AD sign-in logs, we need to have an Azure AD premium subscription, which I think is not a great solution. So Microsoft is actually going to be changing this soon. You'll be able to have access to the Azure AD sign-in logs without requiring those subscriptions. The subscription will control what your retention period is for those logs, but you should be pulling those logs into a SIM anyway. So if we look at these logs, we can see that there obviously is a password spray attack occurring. It's coming from a single IP address, attempting authentication of a bunch of different users in a row. And so we see that there's a specific user, Boba Fett, whose account is fail, 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 and then success. Probably a password spray. Okay, so that's nice to look at visually, but what if they're doing some other interesting thing around that? We need to dig into the details a bit more. Well, we can look at the sign-in error code 50126 and the client app as other clients, older Office clients. This means legacy authentication. So we can build a password spraying rule around this. Now keep in mind what I just did was I password sprayed Office 365, Azure AD. So that means if the organization is federated, these logs are not going to be there. They're going to be on their federation system. So if you have ADFS, those logs are going to be there. So that's where you have to look to figure out what the password spraying is, if it's occurring. And Mark has some more information about that when he covers defense shortly. So a year ago, I talked about attacking AD administration and how to fix it. So let's talk a little bit about our cloud administration and the potential problems with how it's being done today. Active Directory, well known how to administer. We have an MMC, but now we shift over to this Azure AD world where we have to use a web portal or PowerShell. It's very different. It means we're using a web browser now and not the MMC client. We have a bunch of global admins. For some reason, Acme has added a bunch of people to global admins, which isn't the best idea. But a lot of times organizations, when they're going into the cloud, they just put everyone in global admins. But global admins in Azure AD pretty much has as much, if not more, rights than what enterprise admins, domain admins, administrators, schema admins, et cetera, has in AD. It controls the subscription. So it's very powerful. So you really want to pull people out of that if possible, because you don't want a situation where, like Acme, there's people that shouldn't be there and have bad passwords. So the password spray that I just did, I found that there's 2 passwords associated with these user accounts and their global admins. So now I own this environment, probably. But let's say that this didn't work. Let's say that they use pretty good passwords. maybe, like that would happen. And so I go ahead and do a phish. Well, Bleeping Computer a couple weeks ago had a really interesting article about phishing against Office 365. And what I find really fascinating about this phish is that it says your Office 365 license is expired. Update your payment now, or you'll be cut off. No one will have email anymore. Call to action. Very likely an admin's going to click on this. So I'm very happy to be able to state, as a person that doesn't work at Microsoft, that Microsoft has a private preview going on for a role called Global Reader. I'm really excited about this because this provides read access to all of the Office 365 services and their configuration information with no admin or modify rights. This has been sorely lacking in Office 365 for too long, and now it's there, or at least it will be soon. Talk to Microsoft, your TAM. So what this means is you can get these people out of global admin because they just need to look at config info. You can pull these service counts out that may be running PowerShell scripts or doing reporting and add them into global admin. Global Reader. It's still being expanded to cover all the Office 365 services to support read-only only. Read-only only? Yeah, sounds good. There is an article here at the bottom that I link. It's included in the slides. It has more information about Global Reader and why it's going to be more helpful than just Security Reader, because Security Reader doesn't give you read-only configuration information for a number of the services. So let's look at this cloud administration thing and how we can go after that. Well, we have our workstation. Well, we've talked about that before. Compromise an admin in a group that has admin rights on a workstation, compromise the agent, compromise the management system, compromise the traffic, HTTP, hopefully HTTPS traffic to the cloud website. We influence that traffic through DNS. If we can get control of DNS, maybe for some reason there's 300 people in DNS admins, and we can modify the DNS record and point them to somewhere else. Maybe we could get our admin to connect to our system instead of the Microsoft system or the AWS system. And then there's the web browser. So in cloud administration, the web browser is what stores that token, that proof of identity to the cloud environment. And so what's interesting is Google Chrome is one of the most popular browsers in the enterprise because they provide group policy management. So as an attacker, if I can find a way to modify that group policy that controls Google Chrome and force install an extension that is, well, safe, malicious, that enables me to potentially split out that session where I can do something while the admin is still logged into that in that environment, or even extract that token and reuse it somewhere else. That could be pretty interesting. And certainly, if I'm going to do something like that, I wouldn't put a very obvious icon on the browser. I could just hide it. The other thing that's popular in enterprises is the SSL TLS decryption device. This has been pretty standard recommendation since every website is encrypted now. Well, what they do is they break the authentication, they break that web traffic, that SSL session, TLS session from the web browser to the decryption device, open it up, look at all that traffic, and then create a new one to the actual cloud website, and then breaks the response back in order to send that back and forth. That means that if this site is not whitelisted so that the decryption device doesn't open it, the token could be stolen if the attacker is able to actually compromise that device. The attacker could also change that whitelisting rule. So you want to protect your decryption devices and that system to make sure that someone doesn't have access to it. Otherwise, they could impersonate your director of HR, they can impersonate your cloud admin. And then it gets interesting because if somebody could phish the admin, they could get them to go to the attacker's evil proxy, something like EvilGenix or something along those lines. Or if I can influence them to go to a different site and make it look like it's actually the Microsoft site or some other site, I can proxy that authentication through my evil proxy, and even if MFA is enabled, I just show the user the MFA prompt. The other thing that's interesting is, and another common attack, is the password reuse replay, where it usually starts on Twitter where it's like, hey, there might be some stolen passwords, and then like a week later this shows up, password dump with something like a SHA-1 or clear text passwords. We control this looking for the email addresses for the users in Acme and see what we can find. And if we find a password for a user at Acme, we can try that against the Acme environment. Very likely it's going to work. We can also look at the other passwords that's in that dump, try those as part of our password spraying, or in a situation where someone has a unique name that we noticed in Acme and we saw in the password breach, Even if it's a different email address, it might have the same password. So one of the ways to detect this, have I been pwned domain notification, or the password hash sync that Mark is going to talk about in a bit, is going to provide this users with leaked credential report, where you can look to see where these breaches have users with your email address in it. And the last thing I want to talk about as far as this attack goes is illicit consent grant attack, where attackers are phishing users so that they can click and approve an app to have full control of their actual account, their email, and their files, and it's not a true valid app. And then the second big one, I'll mention in a little bit, which is about enterprise app permissions. There's a couple of toolkits that have been released around this first one from FireEye and MDSec. And MDSec was nice enough to have this really nice write-up with graphics, so I'm going to use their graphics. And on the left side, there's an architecture of how this works and how it's configured, but really what I care about is what's on the right. This is what the user sees when they get the phish. And if they're not paying attention, they click accept, then this app has full control of their account, their email, their files, everything. And it's persistent. And the user is likely not going to go back and look at this. This is not a Microsoft Office 365 thing. This is a cloud OAuth thing. So Trend Micro wrote a really interesting article about PawnStorm, where the attacker was phishing Gmail users, targeted, and saying install Google Defender. That sounds like a thing. Sure, yeah, I want Defender to protect my Gmail and my files. And of course, by clicking on this, allow, this attacker group was able to access the files and the email from anywhere through this malicious app. And then the last one I want to talk about is enterprise app permissions. So let's say that I was able to compromise and get a global admin account at Acme. I have that account, I want to use it for a short amount of time, then I want to disappear while they're figuring out all their security stuff. Well, I can create a malicious app that I'm going to call something very similar to what many organizations, especially big ones, will probably have, but I made it up. And this is a great persistence method because as long as I've created it, I have an account in the environment that has owner rights to it, I have some control of this app and all of the permissions that are associated with it. Once they're approved, they persist in that environment. This is why it's important for global admins or admins in a cloud environment to really review the enterprise applications and what permissions they're requesting. Because very much like your phone, you don't want to be in a situation where they have tremendous rights that aren't reviewed or checked for security issues. So let's talk defense.
All right, thanks, Sean, for that. So just to kind of recap, Sean talked really about 6 different types of attacks, right? From consent abuse, from breach replay to password spray. But I thought before we get into this would be a good time to check in on how the Acme project team is feeling after listening to Sean talk for about 20-some minutes. So it feels like everything's on fire, but this is going to be fine because the things that Sean talked about are hypothetical in nature. I have some good news for you and I have some bad news. The bad news is the 3 most common attacks we see at Microsoft are breach replay, phishing, and password spray. But the good news is there's lots of really good fundamental things we can do that prevent these attacks from happening altogether or make them much more difficult to do throughout. And Sean kind of sprinkled around some of these things throughout his talk. And the first one I want to talk about here is compromising the ADFS or Azure AD Connect server. And the key thing here is we want to treat this like a tier 0 resource. It's not news to anybody in this room, I'm assuming, that if an attacker gets onto your domain controller, they can do horrible, terrible things to your environment. The same is true for Azure AD Connect or whatever federation service you're using, like Ping Federate or ADFS. The same is true for that. We want to treat these like a tier 0 resource. We want to protect them like we protect domain controllers. Okay, so let's take a look at the other one. So admin account takeover. The first thing that everyone should be doing to protect their admin accounts is to turn on MFA for your admin accounts. Now you're probably thinking, why are you talking about this? This seems pretty basic. And I agree with you, you're right, I shouldn't have to keep talking about it, but unfortunately, we do. So in September of 2017, at our Microsoft Ignite conference, we looked to see how many global admins had MFA enabled. Who think, like, give me a percentage you guess how many global admins have MFA. Just shout it out, just shout it out. 50%, that's pretty close. It was actually 0.7. So just like a little off. So we talked about it, and we're like, please, go back and do this. So Ignite happened the same time next year, September 2018. What do we think the percent's at now? Another 50%. You have way more faith in your fellow admins than I do. We're up to 1.7%, right? So that means 98% of admins, global admins, do not have MFA enabled. So I asked our awesome data science team, could you pull the numbers for this talk specifically so we have some fresh data for you? And we are up to almost 8%. Yeah, right? Don't clap that. That's 92% that don't have it. That's terrible. That's terrible, okay? God. All right, stay with me. Okay, so I don't get why we're not doing this, but this is one of the best things that you can do to protect yourself. So how can you go back and do this? If you take one thing away from this talk, do this. Go to your admin and click Enable MFA. That's all you got to do. One thing. It's so basic, okay? And the issue with this, though, is you have to remember to keep doing this for any people that get added to these admin roles. So the better thing you can do is use conditional access or our baseline policies for admins, which are in public preview. This will apply MFA to anyone that has that role going forward. The baseline policies, like I said, are in public preview. They are going to change a little bit based on some feedback we've gotten from some customers already, but take a look at that. But the best thing you can do, and Sean kind of alluded to it a little bit, is use a feature we have called Azure AD Privileged Identity Management. This removes all standing admin access. In order to do anything with admin rights, you have to elevate yourself and do MFA. And you can also build some workflows around this to say maybe 2 other global admins have to approve it. You can do as part of a workflow with your change management that they can't elevate until like the change management window. And because PIM becomes this admin center for all of your management, PIM will notify you when people are being added to roles outside of PIM. And some of my customers have found some very interesting things in their environment this way. And PIM works great for Azure AD as well as Office 365, but it also works for Azure resources. So the people that have high privileged accounts to VMs and things like that, you can have them use PIM as well. And this is a P2 license requirement. So like Acme, they can't buy P2 licenses for 500,000 people to start with, but you can buy P2 for your admins. So Acme can buy those 30 or 40 or 50 admins P2 licenses and start using it. And to deploy PIM, it's pretty straightforward. If you go to ak.ms/deployment plans, we walk you through how to deploy lots of Azure AD features like SaaS apps, conditional access, MFA, but we have one for PIM as well. Now, forward thinking for your admins, you want to start looking into FIDO2. FIDO2 is a standards-based passwordless authentication that's made up of 2 parts, WebAuthn and CTAP. I don't have enough time in this session to go over FIDO2. I believe there's a WebAuthn session tomorrow morning. If you're not familiar with this, check it out. But the high level is it's a public private key. The private key is stored on the device. You have to do some sort of like proof of presence, either biometric or PIN. But the reason you want to do this is an extremely strong factor of authentication that makes some of the attacks that Sean showed you either impossible or much harder to complete. And this is really exciting because you can actually go do this today in Azure Active Directory. So we just went public preview with this a few weeks ago. It works for your global admins as well as your authentication admins. Those are the people that control MFA. You can scope this rollout to your users and groups. And if you go to ak.ms/FIDO2docs, we cover more of that stuff there. And you can try this out. Go back and try this on your test tenant. Everybody has a test tenant, right? The silence is just deafening. Okay, we'll do it live. We'll do it in prod, right? So try it with a few accounts. We'll do it live. All right, Windows 10, 1903 for your best experience. It works with Edge and Firefox version 67 and later. All right, the next thing Sean talked about was app consent. So we're not seeing this attack too much yet in Azure Active Directory, but it's something good to be taking a look at. So how to get to this? In Azure Active Directory, if you go to Enterprise Apps, you click on the application, you click Permissions, and you get to see all of the permissions that the application's requiring. And we can see here under Admin Consent, an admin has consented to this application. These are the permissions the application needs. And we also will give you a permission level from low, medium to high and how wide that permission is. And if you click on any of those, we will tell you what that permission actually does. So that's from an admin consent perspective. From a user consent perspective, if you click on that, it will show you the same similar thing, but you can see which users have consented to that application, which is really pretty nice thing to take a look at. Now, some of my customers have like 50, 100. I have a couple of customers that have over 1,000 apps in Azure Active Directory. They can't be clicking through all this. So we actually have a PowerShell script that will help you with this. So this is written by Philippe. He's a feature PM in the Azure Active Directory team. And we're trying to do a lot more work in this area to make this easier for everybody else. But run this PowerShell script. Take a look at what the application permissions are, and you want to look for things like Sean showed you earlier, like anything that has directory read-write all, or any read-write all that looks kind of suspicious. We want to make sure we know what that is. Anything with like a kind of a weird name, like Sean showed you, like, oh, Salesforce 2 looks probably okay. And then anything that an admin has consented to. We want to make sure anyone that has consented to that, we know what that application is used for, and the permissions are okay. So that's what we want to do about admin consent. The other thing Sean talked about was breach replay, right? We find these clear text username and passwords online, and attackers will try them against different services to see if some end user has reused their credentials, which I'm sure nobody has ever done. But the best thing you can do for this, Sean alluded to, is turn on Azure AD Connect password hash sync. And you get two big things with this. The first thing you get is that leaked credential report. So we find these clear text username and passwords. We take those passwords and we run them through the same hashing algorithms as the hashes that are stored in Azure Active Directory. And if the hashes match, that means the same username and password is being used somewhere on the internet. So we will tell you about that. It shows up as a leaked credential, a high-risk user. And if you have identity protection, you can actually block the user on that or put them through a password reset flow. But that's the big thing you get. And you want to be taking a look at this. You want to reset these passwords immediately when a leaked credential shows up. But the second thing you get that may not be obvious is when something catastrophic happens in your environment, like a WannaCry or a NotPetya, you're able to flip your authentication from being federated to authenticate against Azure AD directly. And this gives you two really big benefits. The first benefit is anything in Azure AD will still continue to work. So your business can still use Office 365 and any SaaS apps you've integrated with Azure AD, like Salesforce, Workday, whatever it is, those all continue to still work. But more importantly, this will give you corporate resources to start recovering your environment with. Because if you don't have something like this, it is all hands on deck, all the rules go out the window, and people will be using personal email addresses like Hotmail, Gmail, Comcast.net, or maybe WhatsApp or Facebook chat. And in there, without any retention policies, without any way to do e-discovery, will probably be server names, IP addresses, and probably realistically usernames and passwords in these other things that you have no visibility into. So you want to make sure you have a way for your IT department to start recovering the environment. So take a look at this Wired article if you haven't read it already. Really good, talks about what happened to a couple customers. Now, one of the biggest things I hear against password hash sync is people just really don't understand how it works. They think we're like taking the hash, we're reversing it to a clear text password and storing that, which we're not, or it's the MD4 hash that's being stored in Azure Active Directory, which it's not. So we cover all this here. So take a look at this. This usually answer pretty much anyone's questions around how does password hash sync work. So go take a look at this for anyone that doesn't feel like they need to turn this on. And another thing that I shouldn't have to talk about, but I have to. So we only look for credentials that we find going forward, meaning that we don't keep clear text username and passwords that we found 6 months ago, 8 months ago, a year ago, something like that. But these things tend to get sliced and diced and reposted, so we continue to run through them as we find them. But a couple customers have had this brilliant idea where they're going to leak their own credential. Like, oh, well, should we put it on Pastebin? Like, is that where you're looking for this stuff? Please do not do that. I assure you the service is working. Like, just turn it on, and the leaked credentials, they will come rolling on in. Like, trust me, they always come rolling on in, okay? So you don't need to leak your own credential. So I made this little chart here for anyone that's kind of on the fence about if they should do password hash sync. So we have our pros, we have our con there, which is the security team doesn't want to do it, and then end of list. But I spend a lot of time talking about this with my customers. So if you feel like you can convince me why you can't turn password hash sync on, I would love to hear it. I've done this at several conferences. No one has been able to convince me. If anyone can convince me, it will be the audience here at Black Hat. So come find me after. Our contact information was at the beginning and it will be at the end of the deck. Email me on Twitter is fine, whatever else. I want to understand why you feel like you can't turn on password hash sync. Okay, so phishing. Sean showed a kind of an interesting phishing attack. What can we do? We can require users to do MFA, and the thing we want them to do is use the Authenticator app. This will give you a better performance, but also you'll get less prompts because this acts as a token broker. And there's a few ways to turn on MFA for users. The first way is you can do it at a per user level, and they'll get prompted regardless of what's happening, regardless of what application they're going to. This might be okay if you have a few apps like Office 365 or something like that, but as you move to the cloud, you'll probably want to move to a more dynamic ability to do this with conditional access. You can say if you're coming from this location, or you're coming from this type of device, you want to do MFA that way. But the best thing you can do is you can do a risk-based policy, so we only prompt people for MFA when we think something risky is going on. But no matter how much we do, people are still going to fall for phishing attacks. Internally at Microsoft, there'll be a mail that goes out that says, who would like to take home the brand new secret Xbox to try at home? Shh. We're only taking the first 1,000 people. And people leap at the keyboard to give their credentials up to take this Xbox home, right? So people are going to fall for this. We need to be monitoring for these types of things. So you need to be integrating your logs with your SIEM system. So there's a few ways to do this. The first way, if you've been doing this for a little bit of time, you might be pulling from the graph, and you have like a couple endpoints you're hitting, like the sign-in logs or the auto logs, which is kind of painful because you have to give the time frame correctly, but also then the credentials sometimes get stored in the script because people aren't doing things they should be doing. So that's okay. We want you to move to something else anyways. We want you to use the Azure Event Hub, which is part of Azure Monitor. Now this has some pre-built connectors. So you make a connection once, either with like Splunk or Sumo Logic there, and then the Event Hub will push this event to your SIEM. Just straight push. It's the easiest thing you can do. So go take a look at this. Make sure you're integrating those logs into your SIEM solution. Now, maybe if your SIEM solution is more like a Hotel California, right? Like these events check in, but we never get anything about it. You can use Azure Log Analytics, which has some pre-built workbooks, and also Azure Sentinel. Now, if you have ADFS, one of the best things you can do for this is use Azure AD Connect Health for ADFS. And this gives you a few things. The first thing is you'll get some alerts about common ADFS issues, like your cert's going to expire, or there's some performance issue. But there's a bunch of really good security benefits as well. We will tell you which accounts are having the most invalid login attempts, which may mean someone has an old password on an iPad somewhere that's just like banging away on their mailbox, or maybe this might be a thing of password spray, and we talk about it in terms of risky IP. So we will show you those IP addresses that Sean showed you how to do a password spray, which ones are attacking your environment, okay? And then it's about that, if you have ADFS 2016 or 2019, make sure you turn on Smart Lockout. This helps with this protection, and we'll come back to this here in a little bit. But as in terms of password spray, there's a few big defenses we need to do. The first thing is it's time to modernize our password policy. As Sean showed you, people choose these strong but predictable passwords, right? So if we change it every 30 days, August 2019 with the last special character, right, exclamation point, or every quarter is going to be summer 2019. These very predictable patterns that people do. So we have a white paper on this. Take a look at this. It's written by a good PM on our team named Robin Hickok, and it kind of explains this in a much more deeper detail. And this also is aligned to the guidance from NIST 863B. So what can you do about this? We have this feature called the Azure AD ban password policy that doesn't let you put any of these easily guessable passwords into Azure Active Directory. And we also give you a custom ban password list as well. So put in here things that are specific to your environment. Don't put the IROCU list in here, like you don't need to do that. But just put in things like brands, locations, and common passwords you know people are using. So one of my coworkers was in South America, and he was talking to a customer, and their red team did an internal password spray. And they said over, I think it was 60% of the passwords in their environment had one of the soccer teams in that region in the name. So you probably know that. You have similar things in your environment. That's what should go in this custom banned password list. But the best feature of this, I promise you, the best feature of this is it works with your on-prem Active Directory as well. You can deploy this for your domain controllers. And how that works is there's an agent password filter on the domain controller. There's a member server that's reaching out to the internet to pull down these custom lists as well as the global list. And that's what will protect you against putting these guessable passwords. So you need Azure AD P1. You need to be on domain controllers 2012 or later, but there is no domain or forest functional level requirement. And your sysvol needs to be at DFSR. You should be at that anyways. And you want to deploy this in audit mode first, because you'll see how many passwords it would have blocked. And that's our scoring system up there. We have some fuzzy matching and substring and all that good stuff. We document everything. Take a look at that later. But we'll show you how many we would have blocked. And you can take that to your management and say, look, we have 30%, 40%, maybe even more, 50% easily guessable passwords in our environment. We need to turn this on. And one of the things I've seen people do that's very successful is when they communicate this to their end users, they say, okay, you need to put in a very complex password. But after you do that, you won't have to change your password for 6 months or 9 months or maybe even a year. And people are very excited to go do this and change their password. Okay, so last part here, legacy authentication and password spray. Almost 100% of the attacks we see using password spray are using legacy authentication. This is the POP3, IMAP4, SMTP stuff that Sean talked about. And how often is this happening? So in August of 2018, we saw 200,000 accounts were falling to password spray attacks. So I asked that same awesome data science team, could you pull me some data for this talk? Is it still a real problem? And for May, it was 133,000. In June, it was 212,000. And in July, it was 122,000. So this is still a very active attack that we need to make sure we're defending against. We want to make sure our password policies are up, and we want to turn off these legacy protocols, which I'll cover in a second. But the last thing I want to stress about this, and Sean kind of talked about it a little bit, if you are federated, the authentication takes place at your IDP. You have to take care of this. You have to look for this. You have to block it. The reason the invalid password attempts showed up in Sean's pictures in the sign-in logs is because he's authenticating against Azure AD directly. If you're federated, they will be in these logs. We want to make sure that we are pulling these logs into our SIEM system and we are taking a look at this stuff. Okay? So how can I block this? The first thing, you can block this at Exchange at the mailbox level. You can just turn this off. And if anyone's not using these protocols, turn it off. You can also block it from like a service on your tenant as using authentication policy. This is what Acme should be doing. They're starting this project, turn it off to begin with. Don't let people add accounts that we shouldn't be using. We want to turn this off, so use authentication policies for that. And then we can actually block specific client IP addresses as well using the ADFS Connect Health logs. We see the risky IPs and that kind of stuff. You can actually just drop those connections in exchange to start with. Okay, so if we are federated, in ADFS, we have some authorization rules. And the key thing to know here is that one, authorization rules are very rich, meaning that you can get very, very complex with your rules, however you need to be. But this happens after authentication. And these authorization rules will apply to the entire relying party. So meaning anything behind Azure Active Directory, like Office 365 or any SaaS apps, those will be what's applied to those rules. Okay? And then lastly, we can block this in Azure Active Directory. The first way, again, any users that are not using these legacy protocols today, block it. Turn it off at the mailbox, block it in Azure AD. You can do that using conditional access, or we have a baseline policy that's in public preview, but remember, those are going to change a little bit based on some feedback. But we want to make sure we're blocking those that are not using it today. Don't let it get any worse. Then we want to work through anyone that is using it. So this is probably where you're going to find those older clients, like 2010, maybe that Thunderbird client, and you need to tell people, look, we need to move you to the modern authentication protocols, or you need to move to OWA, but we're going to turn those off. And start with those ones. Those are easier ones to take care of first, like the POP3 IMAP for us. Then you can start worrying about service accounts. So these are going to be using SMTP or EWS. We can start moving those to modern authentication protocols, but you can use conditional access to say these can only authenticate from the internal corporate network. That's better than nothing. We can start with that. And if you're doing apps that use EWS, just be aware that that is going to be decommissioned in October 2020. And if you're doing any conditional access policies based on device, make sure that you have all your matrix figured out so you're not dropping anything that's slipping through. We cover this in this blog post, question 7 specifically. And with that, Sean is going to wrap it up.
Great. Well, thank you, Mark. So now what do you need to do, right? You assemble the team, get everyone together, talk about what needs to get done next. Thankfully, you don't have to go through all these slides to figure out what should really be done because we put together some checklists for you. I hated having to go through a slide deck and trying to figure out, okay, what's all the stuff that I need to do from this? Really, like Mark said, MFA for cloud admin accounts, especially if you're going to be in global admin. If you're going to be in global admin, really PIM is the way to go. You can enforce MFA for global admins and privileged roles through the baseline policies that are in preview or conditional access policies. The other thing that's really important is to make sure that you isolate your cloud admins. As I talked about earlier, if I can control the web browser or the computer itself, then I can own that cloud environment. So we want to make sure that you protect your cloud admins, you get them into either a cloud admin workstation or push them into a VDI or a server for that administration so that at least that cloud admin account, hopefully they have a separate account, not your regular user account, are there to be protected. There's a number of things that we have in the deck that we've gone over. We put together the checklist for you so you have some good information about what you can do on your own. So in conclusion, well, really, the cloud is magic. I mean, it can be very helpful for a business. It can be very useful, but obviously what is helpful and useful and where the data is, that's what the attackers want to go after. So ultimately, there we are. It's magic. So the cloud is a new paradigm that requires special attention, and it's not inherently secure. There is a responsibility for security that's split between the provider and the customer. So as the customer, you need to have a good understanding of what the provider is responsible for and what you need to do as well. So Microsoft provides Office 365 with legacy authentication enabled by default, although at some point that'll change for new tenants. So if you're going in Office 365 now, just turn off legacy authentication because it's not in use if you're just going there now. There's things that you can do to lock this down and tighten them up. The security features and controls, I know they change all the time. It's tough to keep up with. But just do a checkpoint at least every quarter with your cloud provider to see what the updates are and try to figure out what new security controls are available, either in your subscription or maybe one above that might be useful for your environment. Something that wasn't possible 6 months ago may be possible today. And unfortunately, security in the cloud may cost extra, just like on-prem. There may be some security features that you need to have because you have a high security environment. It may cost some additional money for that. So make sure that you budget for that when you're going through the negotiations with your cloud provider. So if you liked our talk, please submit an evaluation. We will be going to the Coral Room for wrap-up right after this. And the presentations will be on adsecurity.org very shortly. That's been our time. Thank you very much for yours.